right? My name is Sathpal, who don't know me, and of course, this is our topic for today: observability demystified, right? So here I am, Associate Director, Cloud Architect at UBS Private Limited, India, and as Atul mentioned, right, I'm a Grafana and Friends Hyderabad organizer, and recently we have launched Global AI Hyderabad chapter. So I'm a chapter lead, one of the chapter lead for Global AI Hyderabad, and it's sponsored by Microsoft. Okay, right. So this is the agenda for today. So we'll start with introduction and importance of observability, core pillars of observability, why observability is critical for microservice and distributed systems, the previous speaker, Shravani, right? Sorry, I did Shravani. So she has set the tone right of what is a microservice, the distributed systems, what is container, right? What are nodes, right? Now you got a gist of it. Now you will be able to understand observability much better. Okay. Observability in action, like we'll see real world examples along with the tools which will be used, right? And key challenges and best practices, future trends in observability, right? So future trends, we all know, right? AI is a buzzing word today, right? So we'll see just an overview, because okay, so how many of your graduates or maybe just passed out or students? Okay, okay, maybe 10 to 15%. Okay, and rest of all are professionals, right? So you do understand about observability, right? Okay, cool. So all right, so before moving on to deep diving into observability, just we'll have some small clip, okay, a funny clip. Let's see this first. सीधा सीधा कुछ नहीं होता है जीवन में, सीधा सीधा कुछ नहीं होता है। मैं आपको एक एग्जांपल देता हूँ। कल मैं बगीचे में गया, मैंने दूर से एक पेड़ पे फल देखे, अब फल को देखा मेरी आंखों में, लेकिन लालच ज्यादा मन, अब मन तो पेड़ की ओर जा नहीं सकता है, तो गया वहां पे मेरे पैर, अब पैर फल को तोड़ नहीं सकते, तोड़ा मेरे हाथों में, हाथ फल को खा नहीं सकते, आया मेरे मुंह में, और मुंह फल को रख नहीं सकता है, तो रखा मेरे पेट पे। और ये सब होते हुए देखा माली ने, माली को आया गुस्सा, उसने आके डंडा मारा मेरी पीठ पे, जब तक पीठ गई पूरे कान से कोई लेना नहीं, डंडा मारा पीठ पे, आंसू आए आंख से, क्योंकि शुरुआत में आंख ने देखा था फल को, फिर सरकार। All right, on a lighter note, right? So this is a funny clip, but if you think logically, right, all the actions which have been in our body parts, right, brain is orchestrating everything, right, all the resources, right. Similarly, in cloud world, Kubernetes is doing the orchestration. The nerves which are there are Kubernetes APIs, right. So understand this way. So how observability is important, right? Because many organizations and many teams, they just ignore infrastructure observability, what I've seen. Okay, so to observe your infrastructure, right, you need to understand about Kubernetes, what is Kubernetes, how it orchestrates the actions, right, when you provision something, how it orchestrates. So I'm just trying to relate that clip with the Kubernetes architecture. Okay, and as I said, right, Shravani has set the tone right. You know about microservices now, you know about containers, you know about nodes. So we'll see infrastructure monitoring plus application monitoring and the tools which are required. So what is observability? The ability to monitor and understand the internal states of a system based on the data it generates, such as logs, metrics, and traces. So we all are aware of logs, metrics, and traces, right? So based on this data, the ability to understand the internal systems, right? So we have to monitor Kubernetes first, that is the infrastructure monitoring, right? And it enables engineers to diagnose and troubleshoot issues, optimize performance, and ensure reliability in complex and distributed systems, right? So we distributed system, what you understand by distributed systems, right? So we have a API, we have multiple APIs, then we have database, then we have a message based application, that is Kafka, we have cache-based application, that is Redis, Denedo, right? So these are distributed systems. When a call is originated, like the request is hit, right? It goes from the source, hops on to other distributed systems and gets back the response, right? So how you monitor the entire trace? Okay, so these are complex systems. So how we monitor, we'll see. And by collecting and analyzing real-time data, of course, these are all real-time data which we analyze from these sources. Observability helps identify system health, detect anomalies, and improve overall application resilience, right? So it's not like we are only doing in a dev or test environment, right? We have to go to production. Okay, so how do you test your resilience? How you will prove, right? How you will tell that, okay, my application is capable of going into production without any issues. Okay, so we should have some measure. Okay, so observability will give that, and it is critical for maintaining high availability and performance in modern cloud native environments. So you have seen overview of the cloud native environments, right? So scalability, high availability are the factors which you need to consider, okay, before you start developing your application. Now, core pillars of observability are metrics, logs, and traces, right? Now, metrics, numerical data points that track system health and performance, right, like CPU usage or the memory, right? There are other as well, but how do you measure? There's a load, so suddenly there's a number of users have increased, right? Let's say in an internet banking scenario, right? So there might be a situation where the load has been increased suddenly. Is the CPU spikes, right? Memory, these resources are important, right? The CPU spikes. So you need to have a measure, like see what is the pattern of your application, right? I mean, when it is spiking, right? So metrics gives that insights. Logs, we all know from monolithic applications till now, logs are really important. The event data that provides detailed timestamp records of system activity. Then diagnostics errors, right? What happened when the service has crashed? You go log in to the maybe server logs or the application logs. You have the timestamp, right? So happened at this time. You go and search for the timestamp, and what you see is, okay, there is a record, there is some error. Then you start debugging, right? So those are logs. Now traces, detailed records of the execution path of a request across services from start to finish. The just I explained, right? From origin of the request till the time it gets the response, right? So that is called trace. So in maybe in application, if you have all the distributed systems, you will see record by record the traces. The origin, let's say it's a database, it will show DB and it will give some SQL error. Next, if it is another microservice, an API call, it will show the name of the API, then it will have timestamp, maybe the method name, whatever. So OpenTelemetry are some of the popular tools which actually helps us give insights of the application, right? We'll see that. Also, these are the core pillars of the observability: metrics, logs, and traces. Okay, now critical for microservices and distributed systems. Now, complexity in microservices, each service might be performing well on its own, but issues arise at the intersections, right? Maybe due to, because the microservice architecture, if you are familiar with it, those are deployed separately, right? Those are in Java terms like maybe Spring Boot applications, separate Spring Boot applications. So they are connected in between, right? So the pods, you understand pods, right? What is a pod, right? Okay, so the pods are running. There is a connectivity between the pods, right? Maybe due to network or some resource issue, one of the pod goes down, but the API where it originated is not the culprit. The next one is the culprit. Now how you will trace it? One team says, okay, there are a couple of teams which are developing, and they say that it's not my issue, right? This happens in the enterprise. If you're working in a enterprise companies, right, and banking, healthcare, other domains, right, it happens. We have distributed systems. We have to understand there is again a production team which says हमें कुछ नहीं पता, right? So they no, these all are the scenarios. No, that's why observability is important. Infrastructure observability is critical. With cloud has come in, and then the development happening on cloud natives, right? Apps developing in a microservices architecture, right? So observability is critical. Okay, and handling failures in distributed system. See, observability allows you to trace issues across multiple nodes or regions in a distributed e-commerce system. Let's say pinpointing where a request failed. For example, you can see a database service or a payment gateway, right? So you can't tell with the like the origin of the request saying that where it failed, but these observability tools help us determine where exactly the issue is, where it has failed, along with the span of your error. Okay, we'll see that. Now, key takeaways like observability helps team navigate increased complexity and decentralize of modern architecture by providing real-time insights. That's what we have been talking about, right? Okay. Now we will talk about the tools. Just to relate with the real world examples and the tools, right? Metrics in action. Prometheus. Now Prometheus is an agent. Now for an application, you have deployed couple of microservices. You have to deploy an agent in the same cluster to get the metrics, right? So Prometheus is a popular tool which collects the metrics. Here again the same CPU and memory usage examples, right? With Grafana visualizing data to track system performance, right? How do you track like the CPU, how many cores of CPU my application is utilizing, how much RAM it is utilizing, right? You define some resources when you deploy your application, that is CPU and RAM memory, right? So those insights can be captured using Prometheus agent. Okay. Now logging with structured and decentralized logs, example is Elk stack, I think everybody knows, right? Elasticsearch, Logstash, then Kibana is dashboarding. Okay. So to collect, store and search logs across services. Now Elk stack is one example. Also Grafana stack has come up, right? There's Loki, right? And it's really doing a good job. We'll see. I have just have a block diagram. We'll see just an example of an application, how the telemetry is collected, where it is pushed, and where it is visualized. Now distributed tracing, that's what I was talking about, right? The open telemetry and Jagger providing end-to-end tracing for requests through services. Real world scenarios, as I explained, right? Slow requests from the front end, right? You have a UI service, microservice, you have a Java backend service, right? You have a Redis cache service, you are having a Kafka topic service, connectors, right? So how the request goes hop on hop and how you actually capture that trace. Okay, so that's about distributed tracing. Yeah, this is what I was talking about. Okay, you can see all the popular tools here, right? The applications and databases. I talked about Kafka, I talked about cluster, I talked about Java, right? And more example, Go. Prometheus needs to be on your application cluster, right? Then only it can collect. Similarly, open telemetry. Open telemetry is quite popular because open telemetry can collect metrics, logs, traces, everything, all the core pillars. We also have profiling, but I will not go in detail about profiling. This is just like basic talk about observability. So these are the three pillars you should definitely know, and how logs are collected, how metrics are collected, how the traces are collected. Open telemetry gives that insights of all these pillars, right? Now it pushes telemetry. Now Grafana Alloy is new it's a agent which has a collector component, collects the metrics and pushes to, you see, Prometheus or open telemetry again. Or I was talking about Loki, logs, Tempo, Mimir. Now why Mimir is important is, anybody knows Cortex? Cortex? No? All right. So Prometheus cannot hold data, right? Large amount of data. Let's say my application has 250 APIs, right? So I have to send metrics, logs, there are a lot of stuff, but Prometheus can't hold it. Okay, you need a mechanism to store data, your historical data. Then how would you see a pattern then? Correct. So Cortex is one component which is based on Prometheus, but now Grafana has come up with its own implementation called Mimir, which is, if you know about HDFS, Hadoop, how Hadoop works is it has 3 copies of your data and it has a cache component as well. So cache is for fast retrieval. If you see the visualization, Grafana can retrieve through cache. Cache holds 2 hours of data, and then it has 3 copies, right? And it also backs up in Azure. Azure has implemented that. What it does, it backs up the data into a blob storage, so that you have your historical data. So for an application to be highly scalable, available, your metrics to be available, right? So you need to have infrastructure monitoring, and that is very critical. You need to and again, this comes with cost as well. It's not like it's open source, but still, where do you get a storage then? My laptop doesn't have that much storage, correct? So that's why Azure, AWS, GCP, these are the providers, right? Storage providers. How you, if you want to see, if you want to implement in your applications, right, you need to have such mechanisms like Mimir, Cortex, right? So you can, these are all open source. Again, open source has a limited functionality, but still they will suffice the purpose. Okay. Now visualization tools, Grafana and Elasticsearch, right? So this is a cycle. Again, the funny video, right? It's a circle. Okay. So and at last they say that कुछ भी सीधा नहीं होता है. It's not straightforward. You might see so many tools, right? And question, अरे इतने सारे tools क्यों चाहिए? Correct, right? So how will I learn these tools, right? So start with the open source projects, right? Try to deploy those projects in any of the kind cluster, or if you have Azure subscription or any AWS subscription, right? Try to deploy them. Try to have Grafana, your visualization tool, right? Try to have Prometheus agent, but that is lightweight. It's not, it's open source, lightweight. You can install, collect the metrics, right? If you want to have logs, right? So Grafana Alloy, day before yesterday, they came up with a new release. What they have done is, now you can, the telemetry data, collected data, can be pushed to multiple backends. Earlier it was only one backend. Prometheus for metrics, Loki for logs, and distributed tracing for your open telemetry, right? So only, no, you can configure only one backend for each of the pillars. Now they have changed it. There's a major update just one day back. They have updated. You can actually push the data, your traces or logs or your metrics, right, to multiple backend sources. That way, it's not restricting your the agent to not to have multiple backend sources and have the visibility of your traces, metrics, or logs. Right? Hope you understand, right? This is again, monolithic application is straightforward. There is nothing much to do. You have a Prometheus agent, you have a Grafana visualization, right? It collects the metrics, you are good enough. But microservices architecture, distributed systems, right? Now is that, I mean, it's very important to have infrastructure monitoring as well as application monitoring. Infrastructure monitoring was completely, observability was completely neglected. Or what happened was, okay, developer used to say, my application is working fine, Kubernetes has crashed down. I mean, the infrastructure has crashed down. How do you mitigate this issue, right? How do you actually observe, right? You go check your logs, how much you will search, right? You need to have a mechanism, you need to have a view of your system, a visibility of your system. That is very important. Infrastructure visibility is very important. That's where you will get confidence of your application going into production. That will work fine, right? Okay. Now, future trends in observability, again, AI is a buzzing word, right? In today's world, we can do lot with AI, right? So one of the things which Grafana came up with is your when you have an alert, okay, so it also suggests what to do with the alert, right? There's a immediate pop-up comes in, and then it says, okay, what to do with this alert. It will suggest something. So that is AI embedded, okay. And automatic root cause analysis. it will prompt you. Let's say my pod has been restarting, continuously restarting, right? You never know, right? You go and search, you go and describe your pod, and you get nothing. There's no events. You go, no, you check your container logs. You see so many logs continuously printing, and you don't understand what to do, right? So that's where AI, if you know, it's already embedded, that will tell you what to do with this. It will actually give you the root cause analysis, or what happened, what can be done. There will be a time where it can also have an action on that alert, right? Let's say your pod has been crashing, right? You you give some instructions like a workbook. So if this is what is happening with my pod, do this action, right? That's what we want, right? We don't want to work on a Saturday or Sunday, right? Generally, production deployments happen on Friday, right? Friday or Thursday, whatever. So you don't want your weekend to be wasted. Use AI. All right. So shift left observability. I have been stressing on this, that infrastructure observability is very important, along with application observability as well. What shift left observability is moving observability practices earlier into your development life cycle, right? Maybe your SRE or DevOps or cloud engineer or platform engineer, cloud architect, whatever you may be, right? It's very important in the early stage of your development, you have this observability practices done, so that you will not waste your time when your application has gone to production. Now your production team comes up with a big list saying that I want these alerts. Now you have double the effort in actually identifying the alerts. Okay, how do I have these alerts? You trace back yourself and see, okay, it's something I have to change in my application now. It's a rework. So you introduce your, using AI, you can do that. You have LLM models, right? Your open source LLM Llama. You can train that model. Okay, you train with your application. What is the need of your application? Okay, every application is of not the same. Okay, so I'm starting maybe a series or blog, something like that, called Observability Pulse. Okay, what Observability Pulse is about, my application which I am working on, developing on, might be different. The softwares which I am using is different than the other teams, correct? So is it the traces, metrics, logs, they have so much of data. What shall I do with the data now, right? That's a big question. How I know, okay, this the information which is collected is helpful for my application monitoring or the infrastructure monitoring. Infrastructure monitoring is common, but for application monitoring, how you understand this data? This is a huge amount of data, right? So observability pulse is like catching the pulse of the application and observing with respect to that application, right? So I'm just I'm writing a blog on that. Maybe you guys also can contribute. I'll publish on LinkedIn. Okay. Okay. Now Q&A. Yeah, tell me.